This is MIMS 5001, Optimization Methods in Engineering. Progress Report. I'm Dan Dimler, and this is the knapsack problem in daily fantasy sports. So first looking at our equations, we're to maximize the summation of the value of an item subject to the item's weight given its maximum weight capacity. And again, this is the 0 to 1 knapsack problem, so we can either choose the item or not choose the item. We can't choose an item more than once. And so what this means in daily fantasy sports, in terms of football, fantasy football, is that we're to maximize the football player, which is the item, and the value, which is the projected points or average points, depending on what our sample sizes are or what data we want to draw from. But basically the points, whatever they are projected to get. And that maximization is subject to the player's weight or their cost to put them on the team. So each player has a salary cost. So the better performing players are typically a higher cost. Better players that have a better average are higher cost than a player that is more streaky. And so we're maximizing this point value based on the maximum salary cost, which is in terms of DraftKings, which is $50,000. And so in doing this, we're using Microsoft Excel. We're using a search algorithm that evaluates players on projected points per salary or average points per salary, depending on what formula we want to use. And this finds the optimum score based on a nodal analysis, branch bound method. So you can see on the right's an example. There are hundreds of players with all ranging different salaries, and so there's just a very big number of combinations we can choose from. So we're going to just optimize that and find out what is the best algorithm to use and which one is going to yield the highest, the optimum points. In our search algorithm, we're going to use a greedy algorithm with Solver based on points per salary rather than a genetic algorithm approach, just for the fact that from the research we've done, it shows that the genetic algorithm in this case usually yields a lower max points, and in this we're looking for the maximum points possible. So here's an example of our optimization model that we've developed. Currently we have all of the players in one column with their given salaries. So you can see the higher performing players have a higher salary. The teams they play for, their opponent, then the fantasy points per game, the beta average or the volatility rate. Obviously we want a player with a that's very non-volatile. The average score, and then also predictions from other websites. And then so we can also we have a option to do a weighted average of those scores in order to optimize them. So basically the optimization model will go through, and also for the art and science of it, we can also include, as in locking players in, or exclude them so that we don't want them in any of our lineups. So if you think Tom Brady's going to have a big game, you can lock him in, and he'll be in the optimum lineup regardless. So from there, this is our optimization criteria, where our maximum salary is $50,000, and the maximum minimum number of players that can be chosen is 9. In terms of positions, we can have one quarterback. So minimum we can have one quarterback, 2 running backs, 3 wide receivers, 1 tight end, and 1 defense. Maximum we can have 1 quarterback, 1 running back, 3 wide receivers, 2 tight ends, and 1 defense. Mainly because of the flex position, we have the ability to choose either a wide receiver, a tight end, or a running back. So in doing so, we will run it using the solver command. We'll see what it gives us. So the solver command goes through It takes all the players. Adds them up, and I think takes them out. It looks like it's taking them out and then finding the optimum. So you see over here our results. Julio Jones, DeAndre Hopkins, Alshon Jeffrey, Geno Smith, Matt Forte, the Broncos defense, and Carlos Hyde, along with Duke Johnson Jr. is our optimal lineup that this optimizer has predicted.